Hi everyone. This is the in this video I will talk about the basic test bench functionality and the key step to performed by test bench, and then automation versus manual work, uh, and why the method matters. So let's start with the basic test bench functionality. The test bench is a critical part of verification process. Its job is to check whether the design under test is working correctly by following a set of well-defined steps. What is test bench? Test bench is a separate piece of code that simulate the environment around the simulate simulate environment around dirt. Send sends inputs to dirt and observe and checks the dirt's output. Think test bench like a lab setup where you test how a machine the dirt re- react to different input. Key steps to perform the test bench: generate stimulus, apply stimulus to dirt, capture the response, check the correctness, and measure against verification goal. Measure process against verification goal. In generate stimulus, create the input signal that exercise the dirt. Can be manual specified or random generated. The manual specified is called direct test and randomly generated is called using constrained random technique. The constrained random technique is the first step if you don't do the direct test. The easy and simple way is doing by manual specification direct test, but the complex way is to do a random generation, which has its own benefit, which is a constrained random technique, CRT, which is also called CRT, constrained random techniques. Apply the stimulus to dirt. Feed the inputs into the dirt as a part of simulation. This step helps simulate real-world use cases. Capture the response. Monitor the dirt's output signals. Save or observe the response to check its correctness later. Check for correctness. Compare the dirt's output to expected result. Use assertion, scoreboard, reference models. If the output is incorrect, this step will help catch the bugs. So here we capture the response, which means the monitor the dirt output and save or observe the response to check its correctness. Then we'll check. Check the correctness. Compare the dirt output with expected result. We use assertion scoreboard reference models. If the output incorrect, this step will be catch the bug. So if there is a the output is incorrect, it will catch when there is a bug. Which inputs, which generated inputs gives you the bug. Measure the process against the verification goal. Keep track of how much of design has been tested. What parts still need verification. Use a functional coverage to measure the completeness. Measure the process against verification. Now we'll see what is the difference when automation and manual work. The simulation generation, it can be automatic or a manual. Apply stimulus, it is always automatic. Capture the response, it is always automatic. Check the correctness, often automatic. Define the expected behavior, this is manual. Create the test scenario, this is manual. You design them. To create a crash scenario will be manual. Measuring the process, often automatic via coverage tool. Why the methodology matters. How you build the test bench. Your methodology affects how easy it is to write and reuse tests. How effective your verification is. How well bugs are caught early. COMS methodology. VMM, UVM, OVM provides the structured way to carry out above steps. How easy to write and reuse the tests. How effective if effect, efficient your verification is. How well bugs are caught early. So these three things are the methodology, and common methodology are VMM, UVM and OVM. Provide structured way to carry out the above steps. In summary, the generate stimulus, create the test input, generate stimulus. The steps for a test bench is generate stimulus, apply stimulus, capture response, check correctness, measure verification. When generate in stimulus, create the test inputs for the DUT. Apply stimulus, feed the inputs to the DUT during simulation. Capture response, record or observe what the DUT output. Check correctness, compare the output to the expected results. Measure verification, track how much of the DUT has been tested. The test bench automates much of the verification work. However, you decide how the test bench is built and how smart it is. A good test bench helps capture bugs early and makes your verification more effective and reliable. So this is it for this video. Next video we'll see the direct testing in verification. Then we'll see verification method basics, and then we'll see the constrained random simulation in verification, and then other topics. Thank you.